Good morning, sir. This is Balaji. We, as a group of four people, worked on this project, and the title of our project is Analyzing Wikipedia Talk Network with GraphX. These are the contents which we are going to discuss in this presentation. Coming to the introduction part, in the era of big data, analyzing large-scale network topologies is crucial for understanding relationships and interactions across various domains. This focuses on graph-based analytics and community detection techniques, utilizing the GraphX library and Apache Spark framework to conduct an extensive community detection analysis on the Wikipedia Talk network. Connected components approach is a fundamental graph analysis technique to uncover community structures within the vast Wikipedia Talk network. Apache Spark's computational capabilities address scalability challenges posed by the data size. Here in this project, we are going to demonstrate the ability of Spark and GraphX to handle big real-world network data set while bridging the fields of graph analytics and social network research.
The main goal of this project is to use a tool called Apache Spark's GraphX to study the Wikipedia talk network. This network represents how people on Wikipedia communicate with each other. We want to find groups of people who talk to each other a lot, kind of like finding different friend groups in a school. We want to figure out who the important people are in these groups and how they work together to share information on Wikipedia. By doing this, we hope to learn more about how people share knowledge online and understand the different groups and important contributors in the Wikipedia Talk network. This can help us understand how information spreads on and how people collaborate on Wikipedia.
In our project, we have taken dataset named Wikipedia Talk Network. Wikipedia, a collaborative global encyclopedia, enables registered users to talk pages for communication and discussion about article updates. Researchers used the January 3, 2008 Wikipedia's complete page edit history to extract all users' talk page changes. These changes include user interactions and discussions. By compiling this data, a network we created illustrating how users connected and interacted through editing one another's talk page. This network serves as a valuable resource to understand the communication dynamics within the Wikipedia community up to January 2008. This network includes all users and their discussions on Wikipedia from its beginning until January 2008. In this network, each node represents a Wikipedia user and a directed edge from node I to node J signifies that user I has edited user J's talk page at least once. Essentially, it utilizes the historical interactions and collaborations among Wikipedia users within this time frame.
Now let's see the workflow. The first step, we will load the graph. First, we will import necessary libraries. Then we will create one variable using GraphX library methods such as graph loader, edge list method. So this will load our graph from dataset file to this variable. So by using this method, that LADA is dotting from RDDs. While it's not explicit in a RDD, but it contains RDD internally to represent vertices and edges, which are then used to construct the graph. Then if we come to second step, after construction of the graph, then we will apply an algorithm, which is one of the famous algorithm in the GraphX library. It's connected component algorithm. Now we will apply this algorithm in that we created graph. So it will identify the uh, it will identify the and label the connected components. The components means it's represent the group or communities of users within the Wikipedia Talk network who are connected through the interactions. The next step, we will find the component size. For this, we will using some operations map and reduce by. So these operations will find the size for each connected components. It will give a unique ID for each connected component, and for that each connected component, it will find size and it gives to that component ID. The next step, sort by size. So we will applying a sorting operation. So it will sort the according to the size of each connected component. The largest size of the connected component in the first, then next it will give in descending order. So in the next step, we will print the results. So first we will create one variable. Then it's a this variable is actually it's an array of key value pairs. It represents the top 50 connected component. So there are many there are lakhs of connected component. So but we are interest to print only 50 results. So then we will print this variable.
So, so let's begin to the implementation part. Initially, we are importing necessary classes from Apache Spark GraphX library to work with graphs. Then we loaded the graph from dataset file by using graph loader function. And then to analyze Wikipedia talk network with GraphX, we used connected components algorithm. So we used for that we used graph connected component function, which computes the connected components of the graph, and each connected component is assigned a unique component ID. And the vertex function extracts the vertices of the connected components, which are represented as tuples containing vertex ID and its connected component ID. And next, calculation of each connected component size. So here we used map function, which transforms each vertex tuple into a new tuple, where the key is component ID and the value is 1. This step essentially assigns a weight of 1 to each vertex, and then we use reduce by key function, which adds up the weights for vertices in the same connected component, effectively for calculating the size of each component. And then later we used sort by function to sort the connected components based on their sizes in ascending order. And next we used collection function, which gives the results by bringing them from the distributed Spark cluster to the local driver program by using collection function, and then reverses the order to get largest connected component first by using reverse function. And in our data set we have used huge number of connected components, so we are printing only top 50 connected components with their components ID and size. This is the output. We got connected component ID, top 50 connected component ID with their size and uh, node ID and also size.
In the dataset, we have a total of 23,94,385 users. As we can see from the results, a total of 23,88,953 users are interconnected to each other in the same component, which is a 99.8% of the total users in the network. This shows that this component represents a highly interconnected community within the Wikipedia. It shows that the larger Wikipedia community and smaller Wikipedia communities collaborate with each other and exchange knowledge. So, in short, we used a tool called Apache Spark's GraphX to find different groups of people talking on Wikipedia. We used a special algorithm to make it work well even with a lot of data. This helped us understand how people on Wikipedia connect with each other. We also found ways to make this tool work faster and better, which can be useful for other things like finding unusual things, making recommendations, and studying social networks. This project shows how helpful graph analysis can be in understanding complicated networks. And here are our team members. I myself, Hanuma, Vaishnavi, Balaji, and Anjaya. Thank you, sir.